All right, this was asked earlier this week, was 2014 number 1. So, grass clippings are placed in a bin where they decompose. From 0 to 30, the time from 0 to 30, the amount of grass clippings remain in the bin is modeled by this. So this is the amount of grass clippings that are left in the bin, where it's measured, AOT is measured in pounds and T is measured in days. So this is how many pounds is left in the bin between 0 and 30 days. So A, find the average rate of A of T over the interval. Average, not instantaneous. Average rate of change is just slope. It's slope from 7th grade. It's y2 minus y1 over x2 minus x1. Or your amount at 30 minus your amount at 0 over 30 minus 0. Now, just put this in your calculator. You're plugging in 30 into this equation, and then you're plugging in 0 into the equation. This is a calculator problem, and you just get negative 0.197 pounds per day because it's a slope. So that means what's happening is you're losing the amount of grass clippings for for the 30 days. Got it? Now B. Find the value of the derivative at 15. Use the correct units to interpret the meaning. It's still a rate of change, but now you're just taking the derivative at 15. So that means, again, if you guys had put this in y1, I would totally have done that in your calculator. Put that in y1 and then have your calculator take the derivative at 15. You should get negative 0.164. And that's still pounds per day. So you have to, that's one point, but then they're asking you to actually interpret the meaning, right? Interpret the meaning. So that means they want a sentence that would say, like, what is this about? We're talking about the amount of grass clippings in the bin is decreasing. How do I know it's decreasing? It's because it's negative. At a rate, how do I know it's a rate? Because that's the question too, of 0.164 pounds per day at day 15. And that would be your sentence. All right, part C. Find the time for which the amount of grass clippings in the bin is equal to the average amount of grass clippings in the bin over the interval from 0 to 30. So they want the average amount of grass clippings. Well, average is that 1 over b minus a times the integral of f of x dx. That's our formula for average. Well, we're going from 0 to 30, so that's going to be 1 over 30 minus 0, so it's going to be 1 over 30. The integral going from 0 to 30 of a of t, the function. Again, this should be in y1, so you can just put this in your calculator. So I'm plugging it in my calculator as 1/30th. Then times the integral. I have this in y1 going from 0 to 30. And you get 2.752. Now, that is not just your answer though. You want to know, when does this equal, at what time does this actually equal the average? So what I'm going to do then is put this answer in y2, and I'm going to graph this in y1 and this in y2 and see where they're equal. So if I do 2.752 in y2, I'm going to graph it. My window is going to go from 0 to 30 because those are the days. And what happens is this is my y1 looks like this, and this is my y2. Alright, so my graph looks like this. I'm now going to find out where they intersect. And that's at t equals 12.418 days. So at 12.418 days, the amount of grass clippings I have equals the average. This is pretty much like a mean value theorem question. And the average equals the instantaneous. Got it? Now, part D. For t greater than 30, the linear approximation L of t to A at t equals 30 is a better model for the amount of grass clippings remaining in the bin. Use L of t, the linear approximation, at the time at which there will be 0.5 pound or half a pound of grass clippings remaining in the bin. Show the work that leads to your answer. Linear approximation. Linear approximation for at t equals 30. Guys, all they're asking for is your tangent line. Y equals y1 plus m times x minus x1. Except we're going to call it a linear approximation, and there's having it at 30. So you have to figure out a of 30 is your y1, slope is derivative at 30, and then x minus, not x, it's t minus 30, because everything's in terms of t. So plug it all in. So as we're plugging it all in, that means a of 30, that means I plugged in 30 into this, you get 0.782. And then I'm going to take the derivative at 30. That means to make your calculator just do the work, and you get negative 0.055. So that means your equation is 0.782 minus 0.055 t minus 30. And then now they're asking you to do is figure it out of when will you have a half a pound. So set this equal to 0.5 and then just do algebra solve for t. T is 35.054. And there you go.